Hi guys, as you can see we're back on the bench. Has been a while after I've posted something on my channel. A lot of life changes and situations got me, but we're back here to do further experimentations, things that which people were waiting for, see if it works or not. So it's gonna be some interesting times to see what's gonna happen. Well, let me get starting. For here, as you can see, I removed the entire setup of the push-pull circuit, the yoke MOSFETs, but not the TL494 circuit. As you can see, it's the same one. So here are the outputs, which are for the FETs. Right now, underneath it, I have it soldered with this wire. These three wires are going to the input of this circuit here. This is the Akula Kacher, as you can see, a bit modified. See, we have all the parts, all the width and amplitude controllers, same type of transistor. For comparison, this was the previous Kacher board with the transistor, same transistor being used, so it's being placed aside. Right now we have it connected up to the Tesla coil. Oh yeah, the grenade. This is also a new grenade. This grenade has an extra layer which is covered with aluminum as a first layer. The winding directions, as many of us know already how to, but now the beginning and the end are at the back side, not the front, so it's a bit different. It's the style of Sergey Alexei. So yeah, it gives us a bit of a different result. So it's we'll be demonstrating just in quite a few moments. This is the Akula Kacher right here. So right now it's being replicated. So let's give it a shot. Do some markings. So let's see. We have 24 volts on. We're feeding it also 24 volts. As you can see, it's pulling almost nothing on amps, not even in arcing, nothing. So yeah, the primary is being fed to 24 volt also. But what's nice is right now we could be powering it from my transformer, which is powering higher voltage to the primary, and having some other greater results depending on how everything works out. So just for the quick here, you could hear the frequency of the push-pull being on the ferrite. Down. Here is where it starts to get the feeling of getting shocked. This is the other end of the aluminum. This is the other end of the aluminum. These are the ends of the grenade. So by changing the frequency, let's say more up. Different sounds, huh? Oh yeah, it burns. Set it back where it was. Had it tuned. Oh well. So I was tuning it straight from the push-pull circuit, and only when in operation to get the right timing I'll be using the widths be controlling. So R8 and R9. R13 will be controlling the amplitude. So power uh, to the collector for the pulses. It's almost to full capacity, almost. And you can hear the hissing of the frequency. Ah. Alright, so quite exciting times having this board finally working. Um, Immediately let me show you guys something else. So this is something that we'll be trying out also. I don't know if you guys are familiar with such a thing, but this was used in one of the guys who also built devices. Never saw no one doing any sort of experiment to the full extent with it before, so I know it would get warm or hot after testing. Basically it has to harvest from a grenade, go straight to this triac, and try to charge the capacitors using ground. So harvesting those positrons and connecting the other end of the ground and see what happens. Alright, so it's all cool. Duty cycle is I have no idea on which percentage it is. What I can say is duty cycle has to be on a certain level. It cannot be less or too much, otherwise I don't get these arc results. This is the arcs could be a bit long, but that doesn't need to be. This is currently operating on 860 something kilohertz. Maybe on the second pin, fourth pin, it's like about 1 megahertz. So you could start imagining the frequency ranges by the tapping points. But as you can see, it's quite different from any other catcher. So now it's being fully controlled. You could control it completely right now via frequency, duty cycle, the widths, and delays. Let me see something. So it's a 7-watt bulb. See if I act as a ground. I'm barefoot. It's nice. Yeah. The aluminum starts to give nasty shocks. It has other properties when being excited by an electric field. Let's see what this does. Amazing. slightly bit different from when the normal catcher is on. So right now it's showing different results in elimination of the gas. In any case, this is what I wanted to show for the updates. Of course, we could raise the frequency till we can't hear it anymore. But you do see an arc, and the arc is white. By the way, we'll be having some scope sessions also. So that's for an update also as well for the guys. And it's currently not connected, so I have the probe just hanging. I'll do another video. We'll be connecting to certain spots on the boards, having a high voltage probe also for to see the waves and the frequency of the test coil. And there we go. And of course we'll be having some readings if necessary with the LCR meter. So it's quite nice to having to see the millihenries or the henries that are from all the coilings that I have. And that's it, guys. There you have it, Akula Kacher from the schematic. It's working. It's really working. Okay. There's